Let's now talk about probability samples. In the slide that comes after this one, we will define what it means for a sample to be a probability sample. But first, let's think about why we might want to do such a thing in the first place. One reason for using probability sampling is that it reduces the bias in our collected sample. But that's not actually the main reason. The main reason we use probability samples is that they allow us to estimate what the bias and chance error in our sample is. We're able to quantify the uncertainty because we're able to calculate both what the average sample should look like and what the probability of our sample looking the way it did was, given our sampling technique. And so those tools allow us to quantify what the bias and what the chance error in our collected sample was. One thing I'll note is that we will use the term probability sample and random sample to mean the same thing here. So finally then, what is a probability sample? Well, a sample is a probability sample if, for any specified set of individuals, you can tell me what the probability of those individuals being in my sample is. It doesn't need to be an easy calculation. You don't necessarily need to be able to write it out by hand, but you need to be able to compute it in some way. Now, it's not true that all individuals in the population need to have the same probability of being included in the sample. That's not required for our sample to be a probability sample. Regardless of if everyone has the same probability of being included or not, you're still able to measure the chance error and the bias because you know the probabilities of our possible samples. Now, before we look at some useful forms of probability samples, I wanted to note that not all probability samples are necessarily good. For instance, suppose I have 3 students, Alan, Kunal, and Ishan, and I want to sample 2 of them. A valid probability sample would be to choose Alan with probability 1 and choose either Kunal or Ishan, each with probability 1/2. This is a probability sample because for any specified set of individuals, I can tell you what the chance of them being in my sample is, right? The chance of the sample Alan and Kunal is 1/2. The chance of the sample Alan and Ishan is 1/2. And the chance of the sample Kunal and Ishan is 0. Right? So this is a probability sample, but it's not so great. Some better probability sampling techniques are what we will look at right now. So the first one we will look at is a random sample with replacement. And here we take random to mean uniformly at random. This is not always true, but in this specific case, it is true. And here with replacement means that the same person could be included in our sample multiple times. And so the mental model you should have for a sample with replacement is, let's say we want to sample with replacement from 100 people. Let's say we have a box with 100 pieces of paper in the box, or 100 tickets in the box, each labeled from 1 to 100. To construct our uniformly at random sample with replacement, what we do is we shuffle up the box, pull out a ticket, look at the number on it and write down that number, and put the number back in the box, shuffle it up again, and keep doing that. So I keep drawing numbers, but after I draw the number, I put it back in the box, so the same number, and so the same person, could be included in the sample multiple times. And that's a sample with replacement. A simple random sample, and so simple is a specific type of random sample, is a sample drawn uniformly at random without replacement. And so the mental model you might want to have for that is, again, have a box with tickets labeled 1 through 100 or 1 through however many people you have, shuffle it up, take one ticket out, write down that number, and then don't put the ticket back into the box. So each person can only be included in your sample once if we are sampling without replacement. A set of specific criteria that a simple random sample needs to satisfy is that every individual needs to have the same chance of being selected, which is also true for a random sample with replacement, right? The uniformly means that everyone has the same probability of being selected. But it also needs to be true that every pair has the same chance of being selected as every pair. And every group of 3 individuals needs to have the same probability of being selected as every other group of 3 individuals, and so on and so forth. And so more generally, in a simple random sample, any group of any subset, I should say, of k individuals needs to have the same probability of being selected as any other group of k individuals from our population. What I want to now do is present you with an example scenario, and what you need to determine is whether or not this is a probability sample, whether or not each student has the same probability of being selected, and lastly, whether or not this is a simple random sample. Okay, so let me present the scenario to you. Suppose you have a class roster with 1,200 students listed alphabetically, and what you do is you pick one of the first 10 students on the list at random. Okay, so you choose student 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. And to create your sample, what you do is you take that student who you chose and take every 10th student listed after that. So if the student you chose from the first 10 is student 8, then you will sample students 8, 18, 28, so on and so forth until 1198, I guess. What I want you to do is pause the video here and answer these 3 questions. And you really should pause the video and think about this on your own. Great, let's take up these problems. So is this a probability sample? Well, one thing to realize is that there are actually only 10 possible samples that we could have, right? We could have the sample consisting of students 1, 11, 21, 31, so on and so forth. We could have the sample consisting of students 2, 12, 22, 32, so on and so forth, all the way until students, 10, 20, 30, so on and so forth. So there are actually only 10 possible samples, and each of them, I should say, occur with probability 1/10. So if the sample you want me to find the probability of is one of those, the chance of it happening is 1/10. And if it's not one of those, the chance of it happening is 0. So this is indeed a probability sample, because for any possible sample, I can tell you what the probability of that being my sample is. Now the question is, does each student have the same probability of being selected? Well, let's think. So in what case does student 23 get selected? Well, they get selected if student 3 gets selected, which happens with probability 1/10, and so student 23 gets selected with probability 1/10 as well. In what case does student 996 get selected? Well, they get selected if student 6 gets selected, which happens with probability 1/10, and so student 996 gets selected with probability 1/10 as well. And so, yes, indeed, each student has the same chance of being chosen. They all are chosen with probability 1/10. And again, the reason it's 1/10 is because we are choosing one of the first 10 students on the list uniformly at random. Now, the last question is this a simple random sample? And now this is the tricky one, right? Because part of the condition for a simple random sample is that every individual needs to have the same chance of being chosen, but that's not the only condition, right? We also need it to be true that every pair of students has the same chance of being chosen, and every group of 3 students has the same chance of being chosen. So, for example, what is the probability that students 8 and 18 are both chosen? Well, they both are chosen with probability 1/10, right? Because if student 8 is chosen, then 18 will automatically be chosen, and 8 is chosen with probability 1/10. So the probability of 8 and 18 occurring in my sample is 1/10. What's the probability of students 8 and 9 occurring in my sample? Well, that'll never happen, right? Because we're only selecting one of the first 10 students, and so 8 and 9 will never exist in the sample together. And so the probability of that happening is 0. And so it's not true that all pairs of students have the same chance of being selected. And so this is not a simple random sample, even though every student on their own has the same chance of being selected. So this is the kind of thought process that we want you to be able to walk through when given an example sampling scenario. We'll wrap up this video with talking about a very common approximation. So we talked about both random sampling with replacement and random sampling without replacement. A very common scenario we will have in the data science realm is that we have a massive population consisting of, tens of thousands, hundreds of thousands, whatever people, and we can only afford to sample a relatively small number of individuals. Okay, and so in this setting where our population is massive and our sample is pretty small compared to that larger population, random sampling both with and without replacement are very close to one another. They're pretty much the same in terms of the probabilities that are computed. And so you might be wondering, why is that? Well, consider a scenario where our population has 100,000 people and our sample is of size 100. Removing 100 people from a group of 100,000 people doesn't really change what the landscape of our population looks like, right? And so the fact that we're sampling without replacement and removing people from the population doesn't really matter that much when we're not removing that many people compared to the larger size of the population. And probabilities for samples with replacement are much easier to compute. So we will often be working in this setting where we are computing probabilities when we are sampling with replacement, and that's an approximation of what the real world might look like. And so in this next video, we will roll up our sleeves and do exactly that. Compute some probabilities when we are sampling with replacement.